Okay, what's going on, guys? In this video, we'll be solving a problem from Geeks for Geeks. So the problem statement is something like this. Generate all binary strings without consecutives 1. Here is our sample input-output. So for k equals 3, that is, we have to generate all the binary string of length 3. We have output 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, and 1, 0, 1. So we can clearly see that there are no strings where there is a consecutive 1. Okay, and similarly for the second input. So let's try to solve this problem. Okay, so for we'll assume the value of k to be 3, and to start out with this problem, what we can do is we can assume that our binary string will either start with 0 or 1. Okay, so let's take this string and I'll name the string n1. Okay, and I'll initialize it with 0. Okay, and after initializing it, I'll call the print function. Now this print function will take the length. So now because I have added I have initialized my string n1 with 0, so we have added one character. This means that the length of that means the value of k should be reduced by 1. So we'll do k minus 1, and then we'll pass our string n1. Similarly, we'll initialize one more string. We'll name this n2, and this time we'll initialize it with 1. Okay, and similarly we'll call the print function, and this will also take k minus 1 and this string n2. Okay, now the logic behind initializing it with either 0 or 1 will be more clear after we'll see this visual illustration. Okay, so here it is. Okay, so you can clearly see that we have started out with these two cases. Okay, we have initialized our string either with a 1 or a 0. Okay, now after 0 is let's just concentrate on the tree on the left. Okay, so first I have added 0 to my string. Now I have two options. Either after adding 0, either I can add a 1 or a 0 again. Okay, so suppose I added a 1. Now because the condition is that no two 1 can occur together, alright, so we cannot add 1. So we have only one option left, that is we can add a 0. Now after this is done, for the next recursive call, the value of k will should be equal to 0. So it should not add any more letters, any more numbers. Okay, all right. So after this is done, we'll backtrack, and then we'll consider the possibility of what if we added a 0 again. Okay. Now if we added a 0 again, then we'll end up with two more possibilities. Either then we can add 1 and or we can add a 0. All right. So let's come to this tree on the right. Now if we added 1, okay, initially in the string n2 we added 1. Okay, so we are left with only one option, that is we can add a 0. Okay, so we have added a 0. Then we have an option of adding either a 0 or a 1. Okay, so we added a 1 or a 0. All right, so the first hurdle of our problem was to come up with a logic. So we have crossed that hurdle. Now the second hurdle is that we have to express this decision making in terms of a code. Okay, so let's try to code this. Okay, so let me write the print function. This print function was taking k as an input and a string. Okay, and let's name this str. Now if the first condition was if the last character of string is 1, then in that case, okay, let's consider 0 first. If 0, then in that case, we are lucky and we have two options with us. We can either add a 1 or a 0. So I'll initialize a new string and I'll call this str1. Okay, I'll copy str in str1 and then I'll add str. I'll add I don't know, maybe we should first add 1. Okay, let's go with 1. So I added, okay, we have to add to str1. Okay, so we'll add 1 to str1. Okay, and please mind that this str is a string, so it should also push back string. Alright, cool. And similarly, we'll make a new string. Let's name this str2. Okay, and we'll also initialize it with str and then str2 dot pushback. Okay, and we'll call the print function recursively. Okay, now this time we'll, because we have added I did one mistake. I should add 0 over here. Okay, now because we have added 1 and 0, so we have to do -1 and we have to pass str1, and similarly we'll pass str2. Okay, now what if we added now what if the what if our string, the binary string, contains 1 in the last position? Okay, so in that case we have only one option left, that is we can add a 0, because otherwise our condition will not be satisfied. So in that case we'll create a string str3, and str3, it will be a copy of str3 dot pushback. Okay, str3 dot pushback, and what should be pushback? Yes, we should push back 0, and then we'll call it recursively. Obviously we'll do k-1 because we have added one letter, added one digit. Okay, and we'll pass str3 this time. Alright, now we have to decide a base condition for this. So yes, the base condition will be that if k is equal to 0, we have to stop. Okay, so we'll say k if k equals 0. In that case we'll just print it out. Okay, print out the string and return. Cool. So let's try to build this and see if our logic is correct or not. Okay, my bad. It should be a character. I'm sorry. It should be a character. Okay, so similarly we'll also add a character over here and here. Okay, cool. So we got our output, and we can see that this is correct output because there are no consecutive 1. Okay, in these binary string. Let's try this code for k equals 4 and see what is the output. Okay, so the output is correct. I hope you get the point, guys. The All we have to do is um, this problem was all about decision making. We have to make a decision. We have to see that, okay, if no, if we have a one with us, we can only go with one option, that is add a zero. But if we have a zero added, we can either go with one or a zero. All right. So I hope you get the idea, the main logic behind the program. All right. So catch you guys in the next one.